An F-35 fighter jet, an offshore wind turbine, and the motor inside an electric vehicle all share a common requirement for getting off the ground. They all depend entirely on rare earth elements. But the name rare earths is a geologic misnomer. These materials are actually found in abundance across the globe. This is a view of a massive coastal mining operation. Australia already extracts thousands of tons of these minerals every year. The country is exceptionally good at pulling these specific rocks out of the ground. The problem is that raw rare earth ore is effectively useless. You cannot pack raw mineral sand into a missile's guidance system. For decades, Western nations focused on the heavy machinery of extraction, while ignoring the complex chemical processing required to turn those rocks into components. To make these minerals functional, that raw ore must be chemically refined and separated, element by element, until you produce pure oxides. This process is difficult to execute at scale, especially when dealing with heavy rare earths like dysprosium and terbium, the elements that allow high-performance magnets to survive extreme heat. Right now, roughly 90% of this specific separation work happens in China. This concentration of power exists because China spent 20 years building this specialized refining infrastructure that the rest of the world neglected. This creates a significant strategic vulnerability. Western nations are currently mining their own soil, shipping the raw material away, and relying on a single overseas supplier to sell the refined products back to them. This unassuming stretch of Western Australian scrubland is the site of a project designed to bypass that global bottleneck. A company called Iluka Resources is using this ground to build Australia's first fully integrated rare earths refinery. The feed material for this plant isn't coming from a new mine. Instead, it's coming from a massive stockpile of monazite, a mineral byproduct that was hoarded in a paddock as industrial waste since the 1990s. The refinery's goal is to extract 4 specific magnetic elements: neodymium, praseodymium, dysprosium, and terbium, directly from these stockpiles. Material that sat idle for 30 years is now the primary feedstock for a project aimed at securing a non-Chinese supply of these heavy elements for the first time. Since its approval in 2022, the project's estimated cost has climbed from $1.2 billion to $1.8 billion, with the completion date slipping to 2027. These delays reflect the complexity of the task. Because Australia has never built a facility of this type, there is no existing local workforce or established technical playbook to follow. That $600 million cost increase represents the price of a nation learning a highly specialized chemical industry from scratch. The Australian government has intervened with a $1.65 billion loan and a secondary facility to cover half of the cost overruns. Canberra is absorbing this financial shock because they have categorized the refinery as a matter of national security rather than a simple business opportunity. Global manufacturers are already responding. A major automaker recently signed a 4-year contract to buy 1,200 tons of the refinery's finished oxides. This deal signals a high level of concern over supply security. A global company is locking in a multi-year contract for a facility that hasn't even finished construction. For over a century, Australia's economy has been built on exporting raw commodities like iron ore and letting other countries handle the high-value processing. Eneabba changes that model by keeping the chemical engineering, specialized jobs, and final product value on Australian soil. The long-term plan is for this site to serve as a regional hub, processing material from other Australian mines and potentially international producers as well. One refinery won't instantly rewrite global trade, but it establishes a functional industrial alternative to a supply chain that has lacked competition for 20 years.